Very good morning to you all.
Good morning, sir.
Morning,
Good morning, sir.
So we are back for mechanics, and last time we had introduced resultant velocity, and you were supposed to go to understanding mechanics. Those of you who don't have a hard copy, there is a soft copy I sent in the group so that people can try out some numbers. Now today we want to advance and use that knowledge we got last time and go to what we call a plane in window conditions. A plane in window conditions. And this plane is basically going to be an aeroplane, and we shall get to know how aeroplanes fly from one destination to another amidst the heavy winds that are in the skies. So in actual sense, the airplane as it's flying does not only fly with its engine velocity, but rather it uses its engine velocity, and at the same time, there is a velocity which is as a result of the wind that is up there in the air. So what happens is that as this wind, if this is the airplane, as it is moving and wind is blowing it, maybe wind is blowing it towards that side, yeah? So at the end of the day, it will move with the resultant, which is the sum of the velocity of the engine plus the velocity of the wind. So you will have two velocities always acting on a given airplane when it is in air. So those two velocities will include the velocity of the airplane itself and the velocity of the wind. So in one way or the other, the resultant velocity, we shall note the following. The resultant velocity will always act along the line from the starting point to the destination. The resultant velocity acts along the line from the starting point to the destination. This is a very important statement in resultant of aeroplanes. How is it important? If an aeroplane is to fly from Nairobi to Kampala, then the straight line joining Nairobi, if this is Nairobi and this is Kampala, the straight line joining Kampala and Nairobi, if this aeroplane is to fly from Kampala to Nairobi, then this line joining Kampala to Nairobi is the line of the resultant. And in that regard, it means that the wind can be going anywhere. Maybe the wind was going east. Then the engine, the aeroplane will have to set a course, which is somewhere this side, so that we sketch an appropriate vector triangle of velocity. So that you see the arrows of velocity of the wind and the arrows of velocity of the aeroplane are following each other. But most importantly, out of this is to know that the line joining the starting point to the destination, this is the starting point, this is the destination. That line is always the line of the resultant velocity. That is the first note. Then the second note. The second note, the velocity of the plane, of the airplane, and the wind must follow each other. In direction. This is when you're using analytical method. So this is the velocity of the plane, this is the velocity of the wind. N of the two has to follow each other. If I have started with the velocity of the wind, then I'll follow it with the velocity of the plane. If I had started with the velocity of the plane, it would look like this. The plane would be having this. Then later on, I would follow it with the velocity of the wind. Just like we had the first ideas we had. So those first ideas are very important in the illustrations we are going to look at in the given examples that are coming ahead. Okay. Now, these questions, in most cases, they are very long questions. So writing them down might be a little bit of a challenge. The good thing, I have a soft copy of Understanding Mechanics. So I'll straight away take you to sharing our Understanding Mechanics. And,
Excuse me, teacher.
yes, please.
I haven't understood the wind parts.
Okay. I was saying, for example, if they have given you a wind that is going east, this is just a mere illustration. The wind was going
So as an actual wind.
Actually, yes, the actual wind. They say the wind is going east. Wind is blowing eastwards. They can say it can go anywhere. But in this case, I'm assuming the wind was going eastwards. Yeah. Then, in most cases, they might say they don't know the direction of the plane. They don't know the direction of the plane, but they can tell you where the plane is starting from to where it's going. Yeah? Maybe this is Nairobi. This is what? Kampala. So in this case, you know where the plane is leaving and where its destination is. If you know that line joining the starting point and the destination, then always that line is the line of the resultant. It is the line joining the entire, because what happens is the resultant is in this way, that a plane can leave Entebbe going to Soroti, but as it is flying, you see it taking a direction of northern Uganda, but it is going to Soroti. Soroti is in the east. The sense is, as the pilot sets the course to north, the wind goes on blowing him towards the east. Because by the time they fly, they know the wind. The plane cannot go in the air unless the people in the control tower have confirmed, the aviation authority have confirmed that the wind is blowing in this direction. So the pilot knows the course to set. If they do not know, then they are not supposed to fly. Why? The wind will blow them to an unknown destination. That is why if there is a storm, no flights are allowed, because that storm can distort motion of the plane. Now, as I was trying to illustrate to you here, I was trying to show you that if you get to know the direction from the starting point to the destination, then I can start by sketching from the beginning here. I sketch the direction of the wind. If I sketch that as the wind, then obviously the plane should follow in a direction so as to arrive at the destination. So the plane should follow in such a direction. Even if they never told you where the direction of the plane is. In most cases, actually, they can ask you, what course should the pilot set? But the reason, because you have this direction and you have this one. If you have any two directions, you can always sketch the resultant. I mean, you can always sketch the appropriate vector triangle. Then also vectorial approach is going to come in very handy here. Because we shall be knowing the direction of the resultant, we shall be knowing either the direction of the wind or the plane. We shall design vectors, and then we equate the I and the J's, and we solve them. That is why the first topic was very important. Whoever did not bother to solve some of those numbers might find a very big challenge in interpreting the word problems coming ahead. So I don't know whether now my explanation for the wind has become better than before. For the lady who asked.
Okay.
Okay.
Thank
So
you.
Can I take an example now? Okay. Here we are. Let's go to an illustration. first example I want to give, it's right here. Okay. So let's, oh, someone has a chat. Yes, I have a number that I tried and failed. Can I? You never sent them the number. If you send the number, I'll always do the numbers. There are numbers I didn't do for friction. Someone sent me numbers of friction. You know, so many people send me numbers and I didn't save all your names. So sometimes you just need to keep reminding me. So you keep on my case. If you don't keep on my case, guys, I have so many things to attend to. So keep on my case if in case you post a number until I give you a solution. Or you sometimes I might not give a full solution. Sometimes I want you also to think. So I give you something half, then I want you to finish it up. Yes, so that I train you to be better students. Okay. So some of us who joined today, I'll check if I have a video to share. Or you can visit my thingy. You can visit my YouTube channel. It's in the names of Ruwama Hamza. Yeah. Most of these topics, I post them there. So visit my YouTube channel, go subscribe, like it, share it. Then you'll enjoy some of those topics that you have missed. Then in case you have a question, you know, what you have not understood, you get back to me. Okay. Now, guys, here is a question. A pilot has to fly his aircraft from airport A to airport B, where B is 600 kilometers due east of A. You hear that statement? They have told you airport A and airport B. The pilot is to fly from point A to point B, where B is 600 kilometers due east of A. This is the direction of the resultant. You know why? Because it is the line joining the starting point to the destination. Remember, those are the keynotes I made earlier. That the line joining the starting point to the destination. If you are to move from where you are to come to where I am, and you draw a line from your home to exactly where I am, this is the line of the resultant. It does not matter whether you get out of your gate, go to the stage, board a taxi, blah, 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 go to the park, blah, 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 board the border bike until you arrive where I am. That is nonsense. The most important thing is that line joining from where you are going to start from to where you go. That line is called the line of the resultant velocity, or the displacement, the resultant displacement line, as we shall see. Now, having identified that, they have said there is a wind of 80 kilometers per hour blowing from northwest. There is a wind of 80 kilometers per hour blowing from northwest. It means it is going southeast. The wind is at 80 kilometers per hour. You see that identification? We need to identify these items very well. Now, they said the aircraft flies at 350 kilometers per hour in still air. Hear that statement. They have not told you where the aircraft is going. They have not given you its direction. They have not given you its compass. They have not given you its angle. Now, the first question says, find the course which the pilot must set and the time taken for the flight. Now, here we are. Firstly, I have already showed you how the line, where the line of the resultant is. The starting point, we saw it's going east. So this is already the line of the resultant. Then there is a wind coming from northwest. If this is the wind coming, I have to sketch the velocity of the wind following the velocity of the plane. So by all means, the plane should be following this direction so as to arrive at our destination, point B. So this I can assume is the velocity of the plane. Because I already know the velocity of the wind, one can say, but teacher, what if someone wanted to begin with the velocity of the plane and I didn't know the direction? How do I sketch? I sketch by making the wind arrive at the destination. By doing this, I can assume this is the velocity of the wind because I already know it. Then I will assume definitely that the plane began from somewhere here. And this becomes the velocity of the plane. Remember, I told you there are always two correct triangles. You either use triangle 1 or you use triangle 2. Now, according to our sense now, we are going to use triangle 2. Now, because the wind was coming from northwest, this angle was 45. Can I sketch this angle as 45? I do not know this angle theta. If this theta goes through here, this angle also is going to be theta. So, having seen how those angles relate, we can use the sine rule. I can take this angle to be beta. So that sine of beta over the resultant velocity, it's the opposite velocity, is equal to sine of 45 over the opposite velocity, which is velocity of the plane, is equal to sine of theta over the opposite velocity, which is the velocity of the wind. Now, according to what we have, we know the velocity of the plane, we know the velocity of the wind. I can use these two equations. If I use these two equations, this is what is going to happen. Sine of 45, the velocity of the plane was given as 300 what? 50. It's going to be equal to sine of what? Theta, we don't know, out of velocity of the wind, which is 80. Can you get me theta? When you press the calc, that is sine 45, which is 0.7071 times 80, divide by 350, then shift sign.
(9.3).
9.3 degrees. But this theta, if I extract out this part, you see this part where theta is? Let me extract it out. It looks like this. If I prolong this one through, this is the theta. And this angle so is also what? Theta. So ideally, in conclusion, the angle is east 9.3 degrees, north is the course the pilot has to set. Or I can come from north. North, 90 minus 9.3, what do you get? You get?
80.69.
80.69 degrees. Going where? East. So those are the courses the pilot has to set. And according to this solution also, that's how this answer came about. Now, there is one other part which has not yet been done. The question goes further and says, find the time taken. Now, can you allow me to use this sketch for the book? This one? It is the same as my sketch. But this is the velocity of the plane. This is the velocity of the wind. As you can see, this arrow follows that arrow. Then this is our line of the resultant, VR. Now, when they ask for time, I forgot this in the notes, but always note, time is got from any known distance divided by the corresponding time. Have you heard that statement? Any known distance, any. The distance can be, for example, time, according to this diagram, time can be SC out of the velocity on SC is velocity of the wind, is equal to CD out of the velocity along that line is velocity of the plane. It is the same time if I use AD out of the velocity VR. That is what the statement means, to have any known distance divided by the corresponding, did I say corresponding time? Sorry, this is supposed to be corresponding velocity or speed. It's supposed to be that, velocity, not speed. I mean, not time. Now, according to the distance we have, the only distance known is AD from here to the destination, which is 600 kilometers. But we don't have VR yet. Can we find the VR? Because you've seen this angle is 9.3. Can you get me this angle? This is 45 plus 9.3 will give us 54.3. So 180 minus 54.3, what do you get? What is the balance here? 1?
125.7.
25.7.
125.7. Okay, so now can we find VR? So sine of 125.7 over VR, we don't know, is going to be equal to sine 45 over the velocity of the wind, which is 350. What is the value of VR? Press the calculator. Someone has a chart. Yeah, it's giving the answer.
$401.96.
401.96 for the small places.
Zero
08, okay. So that is the value of the resultant velocity. Now the time shall be, the known distance is 600 divided by the resultant velocity, which is 401.9608. What time do we get?
$1.4927.
1.4927. What did the question say? The time taken for the flight. Okay, these are hours. If the question had said, how long? It is the same answer. But if the question says, at what time? If you always hear that question of at what time, then in the question, they should have given you reference time. Maybe at noon, maybe at 9, maybe at 11. That's when the pilot started flying. Then they ask you, at what time will he reach Nairobi? That is why when flights are being, those of us who have been at the airport, have we been to the airport, most of us? Adinan, have you been there? If you have been to the airport, the most important communication made is the time. Have you noticed? Guys, do you notice at the airport, the most important communication made is the time? The thing they say is that a flight KLM this arrives at this time. KLM arrives at this time, leaves at this time. KLM is in check-in. Jomo Kenyatta's airline, Uganda Airlines is in check-in for the next 30 minutes. In 30 minutes, it is flying to Nairobi. At 9 a.m., it is flying to Rwanda. The most communication point at the airport is what? Time. That is why it is very sensitive in these cases to talk about time. That is why I'm emphasizing that if the question is set and they ask you at what time, when they say at what time, you must read the clock or you read the watch. How would you read it? You read it as per the question. Maybe the question was saying a pilot has to fly at noon. That is in the beginning. So when they say at what time, add this 1 hour, convert the 1 hour. 1 hour and 60 times 0.4927. How many minutes are out of this 0.4927? Get me those minutes. 60 times 0.4927. Otherwise, you're already done with the question. I'm just emphasizing some items that can come when questions are being said. 60 times 0.4927, what do you get? Some two people have risen their hands. Nashiba, you get?
29.562.
29.56. That is approximately 30 minutes. Okay? Yeah. So if it's approximately 30 minutes, then we say the time the flight will take is approximately 1 hour and 30 minutes. Now, if the question says, at what time will the plane reach airport B? If it is set off at noon, it means noon is 12, not so? So you add 1 hour and 30 minutes. The answer will be 30 hours, which is 1:30 p.m. or 30 minutes after 1 p.m. That is how we read the clock. So with this, you are reading the clock. With this, you're reading the clock. You can read the clock in 24 hours. You can read the clock in 12 hours. I saw people raising hands. Yes, please. Can you pose your questions?
Excuse me, teacher.
Yes, please.
Like when we are sketching the
appropriate triangle.
Yes.
Mm.
Do we have to put emphasis on the direction of the arrows?
Very much, very, very much. If now listen to this statement before you get offline. If the arrow is wrong, for example, do you see this arrow for VP facing up? If you face it down, everything we have done is wrong. Have you heard my statement?
Yes.
If one arrow is wrong, if this arrow has faced up this way for the wind, yet the wind was going where? West, south, what? Southeast. And you are telling us the wind is going northeast. The plane is going to crash. The plane cannot arrive. The greeting at the airport of the plane from UK to Uganda at 6 p.m., it is impossible. That is why the whole number becomes wrong. So drawing a diagram with the correct arrows is very sensitive. That is why if the analytical method is a problem, if drawing a diagram is a problem, we go to vectorial approach. I have some two hands before I can introduce vectorial. Yes, please.
Thank you.
You're welcome.
So what do they mean by when they say find the course?
Find the course. When they say find the course, they are asking you to find the direction one has to take in order to fly. You know,
okay.
Have you ever crossed on a ferry?
No.
Okay. On a ferry, on a boat, on a ship, an aeroplane, when those items get into the ocean, into the waters, into the sky, there is a certain angle, a certain course the pilot has to set, with which they know the dimensions of the wind. That if he's going to Nairobi, he sets a course as if he's going to northern Uganda. Then the wind blows him up to Nairobi. If it is water and you're crossing a river like this, you know, if this is a fast moving river, you can't just cross straight. What do? You swim as if you're going upwards this way. Then the water goes on blowing you slowly, slowly. At the end of the day, you'll arrive here. That is how even a ferry operates.
Oh.
Are you understanding the mechanics?
Yes, teacher.
Even the ferry, even the boats, even people crossing rivers, that is the mechanics they use. They set a course somewhere, then the water current blows them. Even in a plane, the pilot sets a course somewhere, then the wind helps him to blow him to the destination he wants. Okay? Okay, another question before I introduce Vectorial. Someone has risen a hand. Yes? Hanan.
So why did the plane stop at D and not B?
Why did the plane stop at D?
At D and not B.
Okay, very good question. This is ideally, the plane did not stop at B. I mean at D. Okay? In this case, we combined two diagrams at a go. The diagram of velocity and the diagram of displacement. We could not extract both diagrams out. But the idea is the line along AB is the line of the resultant VR, okay? But the distance in actual sense the plane is supposed to travel is supposed to be 600 kilowatt meters, which is supposed to be from A to B. So ideally, I should have said here, this is A what? AB. It actually did not stop at D. It must have finished the journey and reached at B. Is that clear?
Yes, sir. Thank you.
Okay. Now, guys, I want to introduce a second method. Which second method we call the Vectorial what? Approach. So I can leave this here. Let's go back to our clean page. I want you to take a screenshot of the question so that when I ask you the dimensions, you give them to me very well. So hope you already have the questions. So let me go back to the other page. Okay, we are back to this page. Now they have said, first of all, what is the line of the destination? The line of the destination is eastwards. This is point A, point B, and this distance was 600 kilometers. But we don't know this resultant. We can assume it's what? X. Now design a vector for the resultant. The resultant vector is going to be X, which is positive 0. Then they said wind was coming from northwest. Not so. This is now 45. And the wind was at 80 kilometers per hour. So the velocity of the wind, when you resolve, it will be 80 cos 45 and negative 80 sine 45. But with the time when you mature up and you're very good at trigonometry, you don't waste much time writing this. You just say it is 80 over root 2. Negative 80 over root 2. Straight away. You have the direction for the wind. Now, guys, are you all awake and steady? No one is dozing? This is the most sensitive part in Vectorial. They never told us where the plane is going, but they gave us its velocity. You remember? The question said the plane is flying at 350 kilometers per hour in still air, just like that. They never told us it is going east, north, west, neither. They never told us. So if they never told us, shared with us that knowledge, what should we do? We assume. Guys, listen very carefully here. Assume the plane is going anywhere. But let us use common sense. We should use the most appropriate quadrant, which is the first quadrant. I can assume it is going this way. I can assume it's going this way, this way, this way. But those three quadrants are technical. You know why?
No.
They have negatives on them. Trouble will come our way. So we avoid them. All of us, we can now use the cram work and always use the first quadrant only. So we assume it is going at what angle? At theta. The course we don't know, remember. So the velocity of the plane, remember, was 350. So I resolve the velocity of the plane, and I'll have 350 cos theta, 350 sine theta. Is that statement very clear? Is that vector column very clear? Please, if you have a question, raise it. It's a very sensitive vector column I've just discussed now. The one for the plane when the direction is not given. Anyone with a concern there, please raise it before I go to the next step.
Excuse me, teacher.
Yes, please.
So can you please recap on how you've attained the vectors?
Okay. Firstly, we got the resultant column vector. From where? They told us the starting point is from A going to B, and it was going eastwards. So we assumed that is the line of our resultant velocity because it is joining the starting point and the destination. When it joins the starting point and the destination, we assumed the resultant was x, which x is going east, so it is going in the I direction, and it has no component in the j direction. That's why VR became x0. When we came to the wind was coming from northwest, going southeast. So because the wind was going southeast, it was acting at 45 degrees. When you resolve horizontally, you will have 80 cos 45. When you resolve vertically, you will have negative 80 sine 45, because it will be facing south. That's how I came up with this illustration of how the columns can be in terms of having them in that order. This is 80, this is negative 80. So that's how the column VW came about. Then lastly, the one for the plane, which is the most sensitive, we have said, and I've asked you to do this, we can assume the plane is going anywhere, but never assume it is going in this quadrant or this one or this one. Why? Because those quadrants have negatives on them. Those negatives will become technical to analyze at the end for you to confirm the actual direction. But with this first quadrant, it brings out clear answers and solutions that clearly tell us where exactly the plane was going. If it will bring out negatives, it will definitely tell you it was in a different quadrant. You chose the wrong one, which will make an analysis very understandable. But if you choose these other quadrants with the negatives, they might confuse you to interpret at the end to find the actual direction. So when I assumed it is acting at this direction to the horizontal, I resolved VP, which is 350 cos theta. I resolved to the vertical, which is 350 sine theta, and I came up with this column. So having identified VR, VW, VP, the resultant velocity is defined by what equation? We said in vectors, we just add the vector columns we have. With this reason, we can have VR is x0. Do we see that? Is equal to velocity of the wind. The velocity of the wind is 80 over root 2, negative 80 over root 2, plus velocity of the plane, which is 350 sine theta. This is 350 cos theta. With the vectorial approach, the beauty with it, when you look at this column I've just written, you see the answer. Clearly, you can see the answer of theta from this line. Can we get it? 0 is equal to negative 80 over root 2 plus 350 cos of theta. When you make cos theta the subject, this is going to be 80 over root 2 divided by 350. When you confirm theta, what answer do we get? Hanan, your hand is up. Hanan? Someone get me theta. Chebet, your hand is up.
Teacher, why is the VP interchanged? I'm saying again 350 cos theta. It is upside down on the other.
Are you sure? Oh, here. Oh my God. Sorry. This is supposed to be very good eyes. This is cos theta. This is sine. My bad. So this is supposed to be sine. Eh? So this is sine. Guys, have you seen that? It was supposed to be 350 cos theta. Let me erase it. And 350 sine theta. This time instead, I began with what? With sine. Cos theta, sine theta. So the whole of this line, is equivalent. Likewise, the whole of this line can be written equivalent to each other by saying, if I write x is equal to 80 over root 2 plus 350 cos of theta. What theta have we got?
9.30.
9.30, which is the same angle. Okay? Yeah. And of course, this 9.3 was here, which is the same as east. 9.3 degrees going where? North. Remember, you have to state the compass. We don't just leave it as that. Now, cos of 9.3 times 350 plus 8 over root 2. Can you get me the value of the resultant?
$401.967.
401.967. Now, remember I had to confirm which direction is actually the plane is acting. Eh? Now, when you get this theta, this does not confirm. Come back and put it here in the VP. Cos 350 cos of 9.3, what do you get? Otherwise, this one is the same as the answer we got earlier.
$345.399.
Point?
399.
Then the second one?
The sine one. 56.56.
6.5? 6?
Yeah.
Okay. Now listen carefully here. Listen. When I told you about not using other quadrants, when you get this angle, you substitute it here. When you substitute it here, these answers predict where it is lying. Now, according to our answers, we are lucky. The answers are still positive, meaning we are exactly where we are. We are in the first what? Quadrant. But if this one was a negative, the lower one, it would mean we are perhaps somewhere here in the third quadrant, fourth quadrant. If both of them were negatives, we would be here. If the x was negative and the j was positive, we would have been up here. So when you get the angle, substitute it back in the value of VP, and then that column, the signs it will give you will be the signs that will help you to predict whether exactly the quadrant you're dealing with was the right one, or you have to change and analyze a new direction. So with that, you have got x, you have got the direction, you have got time, can be got from any known distance. Remember, the only distance which was given was distance from the starting point to the destination, which was 600. Divide by the velocity along that line, which is the VR, which was our x, which is 600, divided by 401.967. And the answer is 1.496 hours. With this case now, we have used the vectorial approach. Questions before I go to another number?
Yes, teacher. What is x exactly? Is it the magnitude of the resultant velocity?
Exactly. Just like you had, that velocity of the wind was 80. Do you remember that the velocity of the wind was 80?
Yes.
Now I have assumed the velocity of the resultant has a value which is what? X. Is that clear? I have assumed the resultant was X. Just like the velocity of the wind was 80, the velocity of the plane was 350.
Excuse me, teacher.
Yes, please.
My question is, what if after substituting for theta, you get negatives? What do you do?
I'd answered that one, but okay, let me go through it again. Okay. Let me use this space and I show you. Guys, all of you pay attention on this one. The guy's question, I think you've heard it. What if our theta was big? For example, 110. Do you know cos of 110? It's a negative, not so? Let's assume if theta was 110, can you get me the value of VP? It would become 350 cos 110, 350 sine 100 what? What answers would you get? Give me those answers and I take you through that.
Negative 119.7.
Negative 114.7 and
119
119.
and 328.
328.
8.89.
0.89. Okay, very good. Now, look here, guys. When you see that the column is like this, sketch this column vector. Negative 114 is facing what? Faces this way. 114.7. Then 328 is a positive. 328.89. So the resultant is acting along this line. This is what? Velocity of the plane. So the velocity of the plane is acting along this line. Now, when you look at this angle you have got, you can find this angle here. Whereby you would say tan beta is 328.89 divided by 114.7. Kaicheta, what answers do you get? For beta.
2.867.
You get?
No. 70.77.
70.77. Now look here. Look here very well. If this is north, can you get me the balance here? 90 minus 70.77, what do you get? I can call that alpha.
19.22.
19.223. Now, do you see that the direction will be north? 19.23 degrees going where? West. Are you seeing that? Or west, 70.77 going where? North. You see that? Now, another special student will say, me, I want to give the answer in a bearing from north, sweet up to there. Do you know that this is 270 plus 70.7? You'll get what? 340.77 degrees. This is also correct. This is correct. This is correct. So, in case it has a negative somewhere, in case one of the values that have come up has a negative, it means you draw the diagram and analyze and see where exactly in that quadrant, how the angle is behaving so that you get the correct direction. But that is only very possible. I'm saying very possible, even others it is possible, but very most possible when you use the first quadrant. It is very appropriate in the first what? Quadrant, rather than the other quadrants. So my friend who has asked that question, in case it was a negative, I think I've answered you right. Have I tried to answer you very well?
Yes, sir. Thank you.
You're welcome. Any other question before we go for another number? This time round, I don't want you to say that you don't have the page right. The page of understanding mechanics is the page, let me see the page, where are you? Page 222. Page 222, you're going to land on our numbers. The exercise is on page 224 and 223, understanding mechanics. If you get done with understanding mechanics, let me know and I send you other interesting books. You need to do Bostow, you need to do Humphrey. If you do all these three books, there is no mechanics number that can handle you. Instead, you'll be the one to handle every number of mechanics. Okay, I've seen a number I'm going to do already. If you're ready, you let me know. We go for this number 18. Those numbers are quite many. When you try them out, I will answer some of the questions on the platform of WhatsApp. Then I'll come and attempt only 2 challenging ones in the next lesson before I introduce crossing a river. So the next lesson, I will attempt 2 challenging numbers that you found very bloody numbers. But the rest, in the meantime, in case between now and Monday, when you do this exercise, those that will be challenging, you'll get back to me. But allow me not to give you the full solution. I will give you, for example, like diagrams. Maybe I'll first look at the diagram you've sketched. Then I tell you this diagram is wrong, adjust it so that I guide you. I don't want to just give you solutions. I want to train you how to do the numbers, not to just give you answers. If I give you answers, I'm not helping you much. I need to give you guidance on how to get the answers. So in case you send a number and I just send you a guide, please go ahead and think. Don't say that teacher is mean. I'm not mean. I'm just doing you better. Okay. Another number. Here I am. There's number 18. There's number 18. There's number 19. How about your time? Allow me to do number 18 using both methods. Okay. Guys, can you all see number 18? told us an airfield A is 500 kilometers due south of airfield B. Already that is the line of the resultant, one should know. A pilot wishing to fly his aircraft from A to B is told that there is a wind of 50 kilometers per hour blowing from north 60 degrees east. Very good illustration. Are you hearing that statement? There is a wind. Signals come from the aviation authority that there is a wind coming from north 60 degrees east. Do you know where that wind is going? If I tell you that the wind is coming from your school, what does it mean? It means the wind is leaving school. Huh? Going somewhere. So here they're telling you a wind is blowing from north 60 degrees east. It means it is leaving the quadrant of northeast. It is going to the quadrant of what? Which quadrant is it going to? Those are very important statements. Someone interpret for me that. Where is the wind going? To which quadrant? Someone?
First quadrant.
First quadrant. You read the statement. A wind is blowing from north. Look here. This is the sketch. North. A wind is blowing from north 60 degrees east. It is blowing from this way, going this way. Is that clear? Are you seeing where the wind is going? What you read is what you interpret. They have said in still air, a plane can fly at 300 kilometers per hour. We don't know where the plane is going. What course should the pilot set in order to reach B? Find how long the flight will take. Let us first handle those two. Okay. According to the situation, we have seen, firstly, they told us a pilot wishes to fly from A going to B. From A to B, the arrows face where? Up. This is the line of the what? The resultant. We have the velocity of the wind. We don't have the velocity of the plane, I mean the direction of the plane. So we shall start with this direction of the plane. Who is crossing in my work? We shall start with the direction of the plane from the starting point. Now, pay good attention here because there is a thought we are going to look at here. We need to think very well. If I think clearly, this is how my line of the resultant is acting. This is point A, this is point B. The wind is going where? This way. Velocity of the wind. Then the pilot has to direct himself somewhere this way until he reaches what? B. Do you see that the arrows are following each other? If one wanted to draw the alternative would look like this. One would have ended with the velocity of the what? Of the wind at the destination. Then the pilot would have set a course somewhere up this way. Remember, I told you, your diagram should be able to illustrate the two possible appropriate triangles. If it cannot, it is wrong. That is the sketch. Any question before I bring in the calculations? Any question on the sketch? How I've brought about the sketch? What has happened? because now we need to analyze the angles we have. So if no questions on the sketch, look here.
Sir, I've not understood.
Pardon? You've not understood? Hello?
The direction of the wind.
Of the wind, eh?
I've not got the direction. Yeah.
Okay. The wind, they told us, the wind of 50 kilometers per hour was blowing from north, was coming from north 60 degrees east. So it was 60 degrees east is here. If this is our north, our east is this way. So this is 60 degrees east. The wind is coming from this way, going this side. That's why the wind went in west of south. At this is going to be 60, this is going to be 30. So if this is 30, it means this angle here is 30. Remember, this is going to also be what? 90. So that is how the wind ended up in that direction. Is that better? Chasimire, praise. Your hand is up.
I'm inquiring on the direction of the wind.
Mm.
So why the arrow is facing up?
Why isn't the arrow facing up?
Oh.
Okay, if the arrow was facing up, if it was to face up, it would mean the wind is going in the direction north, 60 degrees east. But because they said the wind is coming from this direction, it means it is going in this opposite direction. Just like I can say, the wind is coming from your home to me. It means the wind is moving from your home towards myself. If I say the wind is coming from me to you, it means the wind is blowing from my side, coming to your side. Does that make sense now?
Yes, sir. Thank you.
You're welcome. So are we ready for the angle? Look at this angle. Do you see that this angle is going to be 120? Now, there's a thing I want to handle at once here. You see what the question said? Eh? Assuming the wind does not change this final bit, how long would the return flight take? I'm going to handle this number at once because time is flying so fast. Otherwise, you can handle it bit by bit. If I assume this is x, the velocity of the plane was 300. The velocity of the wind was 50. Do you see that we have Vp squared is equal to Vw squared plus Vr squared minus 2Vw Vr cos 120 using the cosine rule. When I use cosine rule, pay attention again, you shall have 300 squared is equal to 50 squared plus x squared minus 100x cos of 120. 100x has come from 2 times 50 times x. Cos of 120 is a negative half, I think. If it's a negative half, you will have 90000 is equal to 2500 plus x squared plus 50x. We get a quadratic equation which is x squared plus 50x minus 90,000 minus 2,500, you remain with 80,700, 7,200 and 7,500 is equal to 0. Isn't it? Press your calculators and get me the values of x. You'll get two x values. x1, you'll also get x2. You know why I brought this method to your attention? Whenever we have a return journey, and the wind is the same, and the velocity of the plane is the same, everything does not change, apart from maybe changing the course. When you use this technique, you get two answers. One answer is positive, the other answer is negative. The positive answer is the fast going. The negative answer is the return journey. What answers do we have? You will use the other methods I've used earlier to confirm in your free time and try out the same number and check and see. Yes, Namgen.
When you were using the cosine rule,
Mm.
I thought it would be VW because the angle is for the A, I think.
You say you thought it would be what?
VW squared is equal to VP squared.
No, no reason being, this angle is opposite to this side. So this side is where we have VP. So it is supposed to be VP squared is equal to VW squared plus VR squared. Who has COVID? Is that clear?
Yes, yes. I thought it's A is equal to, I thought it's A squared is equal to B squared plus C
Ideally,
squared.
this is the side of A because this is the angle capital A. Don't you?
Yeah.
Then this is small b, this is side small what? So it is small a squared is equal to small b squared plus small c squared minus 2bc cos of what? Capital A.
Thank you.
That's what I've used. Okay. Guys, answers, time is chasing us.
It's 271.85, 271.86 after rounding off. Then the other is negativity of 321.86.
Okay, very good. Now, this is what I was saying. So this is the resultant on the first going. So this resultant can help you find time one. Sometimes even they ask you, what is the total time for the whole journey to and fro? So you get the first time when it's going, the resultant velocity, remember, is acting along which distance? 500 out of the first resultant, which is 271.86. You get the time. Then the second time, T2 shall be got from 500 over the return resultant, which is 321.86. So they have said, how long would the return flight take? The first question said, what course should the pilot set? All those can be now answered. What course? Did we get the course? We have not yet got the course. The course, we can assume it's this one. Let's assume it's beta. Then we use sine beta over VR is equal to sine 120 over 300 is equal to sine VR, we have got 271. Let's use these two. So one can say sine beta, the first VR is 271.86 is equal to sine 120 over 300. Can you get me better?
51.7. 51.7.
51.7. Now, the challenging bit here, we need to analyze. Now, let's take a look at this. We have a V of the wind. Then we have a VP. But this angle we have seen is 51.7. But look here. This wind, this angle was 30. This was 60. So it means this is 30. The whole of this is what? 60. Now, if the whole of this is 60, there is a balance which has remained here. 51.7 minus 60, what do you get? You get 9.3 over 8.3. 8.3, I think. You get 8.3?
Yes, it's 8.2.
So if I count from north, because now this is my north, so I go towards this side up to here. So the angle is north, 8.3 degrees, going where? East. If one wants to start from east, we'll start with the 30 plus this angle, 51.73, which is east, 81.7, going where? North. So that's the conclusion for the direction one has to set. Then get me this time. I have not got a number which has from a given time. But according to the numbers which are in this exercise, you'll find them with the reference time. 500 divided by 271.86 for the time ongoing. So this is time T1.
1.839.
1.8.
But it's like I told you, it is 1 hour. 1 hour. 0.839 times 60. What do you get?
$110.35.
No, wait. 0.839 times 60.
50.34.
50 point?
50.34.
Okay, so it's 1 hour and 54 minutes. Okay, that is ongoing. Then this one on coming back, what answer do you get? 500 divided by 3121.86.
One point five five.
1.35. 5535, which is 1 hour and 0.5535 times 60.
33.21.
30? 33.